Hey, what's up, y'all? So today we're going to be talking about simplifying radicals. There are multiple ways to do it. You could pull out a factor that is a perfect square, or I've seen people use the factor tree. Today we are going to focus on that factor tree method. This is really a method you could use if you're finding that you're struggling to find those perfect squares. All right, so let's just kind of get into some examples and work it out, and then at the end of this video on Edpuzzle there will be some extra questions posted. All right, just for example one, we got the square root of 32. So when we use the factor tree method, what we are doing is we are using a property of radicals, given that we can break up a radical into a factor of other radicals. So square root of 32 is just the square root of 16 times the square root of 2. All right, and I can do that if you're kind of struggling pulling out factors. Just remember, right, if you have a 2 on the end, or if you have an even number on the end, we can always take out 2. Always start there when you're doing your factor tree, okay? Square root of 16, square root of 2. Some of you might already be shouting out the answer, but let's not ruin it for others because that method may be working for you a little bit better. But it may also be useful to continue that factor tree down, and you want to look for pairs, right? Because this is the square root of 4 times the square root of 4, which is going to always give us exactly what's inside the radical. So when we find that pair, that's what we're looking for. Then we can pull out the number inside the radical all by itself, okay? Square root of 4 times the square root of 4 is equal to 4, okay? All right, and then because this one doesn't have a pair with it, I like to say that these two left the house, which is the radical, and went to the dance. The 2, square root of 2, doesn't have a date. Staying in the house, stays there. We're simplified as the square root of 2, okay? So we got 4 times the square root of 2 once we simplify the square root of 32. All right, let's look at another example, just different numbers, same vibe. We have the square root of 45. All right. We can do the same thing. Let's say you're trying to find some factors. Thinking. We get 3 and 15, right? And it's the square root of 3, square root of 15. Those don't work nicely. Once again, I do have to remind for the people who are doing it the other way, all right, I got you, and you're right, and just don't ruin it for the other people who might be struggling pulling out those perfect squares. We got 3 root 15. We can break this down, square root of 3, square root of 5, okay? And the nice thing is we want to find our pairs. These two pair up. They are a perfect pair. They go on a date. They leave the house. They leave the house as a 3, all right? This square root of 5 doesn't have a date, ends up staying in the house, so we can write that as the square root of 5. So this works because this is all multiplication. The square root of 3 times the square root of 3 is going to be 3. The thing that if we multiply it by itself would give us 3, well, when we multiply it by itself, we're going to get 3. So it logically makes sense that this works out. Okay, let's do one with the coefficient in front. All right, we got 3, actually, I'm going to do this one. Negative 2 times the square root of 250. All right, and we want to simplify that down. Let's break it down this way, right? We got square root of 25, square root of 10, still don't find any pairs. Square root of 5, square root of 5, and then this can break down square root of 5 and square root of 2. We're just breaking it down to its prime factors or until we find a pair that works for us. We found a pair and it happens to be part of the prime factors. We have 2 of the 5s and we're only going to put 2 of them together, no more, okay, no less. These ones, okay, they both don't have dates. They also both don't match. We're just going to multiply those back up, and they're still going to hang out with each other in the house. Okay? We also need to make sure we're careful not to forget that -2. So what we're going to end up with is -2 multiplied by this pair, which comes out and gives us 5. All right, multiplied by the square root of 5 and the square root of 2. We keep the radicals together. We keep the coefficients together. All right, and we will end up with -10 times the square root of 10.